Welcome back. Let's begin our architectural review. Let's address the cloud-shaped elephant in the room. If your AWS bill feels out of control, the explanation is usually not pricing. It's architectural alignment. It is fundamental to the system. AWS is not inherently expensive. Unstructured complexity is expensive, and AWS is exceptionally precise at measuring the consequences of how a system is designed. This is not a FinOps video. This is not about discounts, reservations, or dashboards. This is about systems thinking. Cloud platforms don't punish teams. They provide feedback. And feedback, when we're willing to examine it, is incredibly valuable. AWS doesn't argue. It invoices. And invoices are simply signals about how our systems behave. In most AWS environments I review, between 30 and 70% of spend is avoidable, not because the teams are unskilled, but because cloud platforms are unforgiving to architectural misalignment. Modern systems amplify small inefficiencies, designed for hypothetical scale, and you pay for capacity you don't use. Add layers just in case, and networking becomes a recurring tax. Choose heavyweight tooling early, and idle infrastructure becomes your baseline. None of these decisions look dramatic on their own. That's the problem. Systems don't penalize individual decisions. They accumulate them. Cloud billing is accumulation made visible. It calculates the cost. Mistake number 1, EC2 as emotional support compute. Using EC2 in 2026 is like buying a forklift because you might move a couch someday. It feels prudent, it feels prepared, it feels controlled. But most modern workloads are not steady-state systems. They are sporadic, bursty, idle for long stretches, triggered by human interaction or asynchronous events. That is not constant demand. That is probabilistic demand, and it does not align with fixed infrastructure. EC2 is a steady-state machine. It assumes baseline load. It assumes predictable utilization. It assumes that the server being on means it should be doing something useful. When those assumptions don't hold, you are not gaining resilience. You are introducing idle capacity as a permanent cost floor. EC2 is absolutely correct when you have consistent baseline traffic, but not if your traffic graph looks like a heartbeat monitor after 3 espressos. Lambda is not toy compute. It is an economic model. You pay for execution, not for availability. For spiky loads, Lambda must be your first option consideration. You convert variability into cost efficiency. And in cloud systems, variability is the norm, not the exception. And compute is just the first of architectural mistakes you could make. Mistake number 2, the sacred VPC temple. VPC design is where cost gravity often hides. Many architectures centralize network control to maximize isolation. Everything is private, behind a NAT gateway. Traffic crosses availability zones by default. All communication routes through layered controls. On paper, this looks disciplined. It looks secure. It looks enterprise-ready. But cloud networking is not free abstraction. Network hops become billable fast. Every cross-AZ transfer has a cost. Every NAT traversal introduces both latency and recurring charges. Individually, these are small numbers. Systemically, they compound. AWS Managed Services, S3, DynamoDB, SNS, SQS, are already designed for secure public access. Public endpoint does not mean public exposure. It means identity-based access control instead of network-based isolation. Lambda does not need to live inside a VPC unless it must reach private resources. In cloud systems, unnecessary networking is not protection. It is recurring architecture. Notice what's happening. This started as a compute decision, and it's already spreading into architecture. This is systemic. Mistake number 3, Kafka and enterprise cosplay. Kafka is an excellent distributed system. It is also one of the heaviest tools available in the managed cloud ecosystem. That combination makes it powerful and easy to misapply. Many workloads do not require partition management or broker clusters. They require reliable decoupling, or event fan-out, or ordered processing. Tooling decisions are often made before workload characteristics are understood. And heavy tooling introduces heavy assumptions. For low message volume use, SQS. For event fan-out use, SNS. MSK is not wrong. It is weight, and weight changes system economics. It introduces operational overhead and cluster lifecycle management. When workload volume is modest, those costs do not disappear. They become baseline. Cloud does not penalize ambition, but it does price complexity. Mistake number 4, Kubernetes as a default religion. Kubernetes is a powerful orchestration system. It is also a structural commitment. When you deploy EKS, you are not simply choosing compute. You are introducing a continuously running platform, control plane, worker nodes, networking layers, add-ons. Those components exist whether your workload is active or not. I routinely see clusters running 24 hours a day for workloads active only a few hours. That is not inefficiency in Kubernetes. It is a mismatch between platform weight and workload demand. Kubernetes makes sense when you have multiple teams and clear platform ownership. In that context, the cost floor is justified. But for a small workload, the economics shift. You do not gain elasticity, you gain permanence. And permanence introduces baseline cost. For unpredictable workloads, consider using Lambda. For containers without platform overhead, try ECS. Kubernetes is not excessive. It is heavy. And heavy systems require sustained utilization to justify their cost structure. Cloud does not discount unused orchestration. It prices it. Mistake number 5. Microservices as lifestyle branding. Microservices are not inherently superior architecture. They are a response to organizational scale. They exist to enable multiple autonomous teams to work independently. When that condition exists, distribution creates value. But when a single team owns the entire system, splitting it into many services does not increase scalability. It increases coordination surface. Every additional service introduces a deployment pipeline, IAM boundaries, network communication, observability complexity, and failure isolation. Individually, these costs appear small. Systemically, they accumulate, and accumulation becomes overhead. A modular monolith often provides clear boundaries and lower operational load for years. Microservices should emerge when team structure demands it, not before, because distribution is not free. It moves complexity from the codebase into the network. And in cloud systems, network complexity is billable. Mistake number 6. S3 as a digital landfill. S3 is inexpensive, but inexpensive storage does not eliminate lifecycle cost. In most environments, buckets accumulate logs with no retention boundary, backups without restore validation, build artifacts without expiration, and data retained for safety. Individually, each object is negligible. Systemically, retention without intent creates structural growth, and structural growth becomes baseline cost. The real expense is rarely storage alone. It is retrieval, cross-region replication, data transfer, compliance surface area, and operational ambiguity. Lifecycle policies are not merely optimization tools. They are architectural constraints. They define how long data lives, who owns it, when it expires, and what class it belongs to. Glacier is not overflow storage. It is archival storage. Archival implies access pattern clarity and deletion schedules. If data has no exit strategy, the architecture is incomplete. Cloud storage is elastic, but retention decisions are not. And in long-running systems, indefinite retention becomes permanent cost. Mistake number 7. Overprovisioning as fear. Oversizing resources feels conservative. In cloud systems, it is a structural commitment. I routinely see ECS tasks configured with multiples of required memory, RDS instances sized for projected peak scenarios, and Lambda functions allocated far beyond usage. The intention is resilience. The outcome is fixed capacity. Cloud elasticity is designed to scale with demand. But when capacity is provisioned for hypothetical peak load, elasticity is bypassed. You convert dynamic infrastructure into steady-state cost. If average utilization sits below 40%, the issue is not readiness. It is misalignment between demand and capacity. CloudWatch provides utilization signals. Auto-scaling adjusts supply to match load. Right-sizing aligns baseline cost with observed behavior. Elasticity is not automatic. It requires architectural trust. And when elasticity is ignored, capacity becomes permanent. Permanent capacity becomes baseline, and baseline cost is difficult to remove later. Architectural discipline compounds. So does unused capacity. As you see, this is one pattern wearing 7 disguises. High AWS bills are rarely pricing problems. They are architectural signals. This is the lesson. Look at the patterns. Fixed infrastructure for variable demand. Network isolation on managed services. Heavy tooling before workload scale. Platform infrastructure without utilization, service distribution ahead of organizational scale, data retained without lifecycle boundaries, and capacity provisioned beyond demand. None of these are irrational in isolation, but systems do not operate in isolation. They accumulate structure, and accumulated structure has economic consequence. When workload, tooling, organizational scale, and capacity are not aligned, cost becomes visible. AWS does not reward optimism. It measures behavior. And measurement at scale is precise. So how do you actually reduce AWS cost? Not by negotiating pricing, not by layering reporting tools on top of structural inefficiency. You reduce cost the same way you improve reliability, by aligning architecture with reality. Align compute with workload behavior. For variable demand, utilize variable infrastructure. Align tooling weight with system scale. Choose the lightest abstraction that satisfies the requirement. Align service boundaries with team structure. Distribute when coordination demands it, not before. Align data retention with lifecycle intent. Every object should have a reason to exist and a defined end. Align capacity with observed utilization, and let elasticity function as designed. Cost reduction is not an accounting exercise. It is architectural calibration. When workload, tooling, organization, and capacity are aligned, complexity decreases. And when complexity decreases, cost follows. Design decisions compound. So does misalignment. AWS is a mirror. If the reflection looks expensive, the solution is not to challenge the mirror. It is to recalibrate the system that the mirror reflects. Cloud platforms do not invent cost. They expose structure. AWS isn't expensive. Misalignment is, and the invoice is simply the measurement of how the system behaves. If parts of this felt familiar, that's normal. These patterns appear in almost every growing cloud environment. The opportunity is not to defend them, it is to refine them. Because architectural maturity is not about avoiding mistakes. It is about recognizing structural patterns and redesigning with intent. Thank you for watching.